everything worked out well last week with the videos. Today we are going to, the first video we're going to do is we're going to do the review questions for Module 10, and then we will go over the practice problems as well for Module 10. Hopefully I can go through these pretty quickly, and if you had any questions, they should be able to clear up all of your questions afterwards. So, alright, so let's start with number 1. So state whether the substance described is most likely an acid or a base. So the first one says a substance that tastes bitter. Well, it's easy to remember because the two B's go together. Bitter, base, okay? An acid's going to taste sour, kind of like a lemon. A base is going to taste bitter. The next one says a substance that feels slippery. So if you're thinking to yourself, you know that a lot of the soaps are bases, and so if you put soap on your hand, it's going to kind of feel slippery. So a base is going to feel slippery, but an acid, it doesn't feel slippery, but it's going to be able to conduct electricity. So those are two differences there. And then the last one says a substance that turns blue litmus paper red. So I know it's kind of hard. Sometimes you might get confused because one goes blue to red to blue. Always think endpoint. What is the color after it changes? If it's red, it's an acid. If it's a blue base, so it's easy to remember blue base. So whatever the final outcome is. So if it's a blue turning red, the final result is red, so you know it's going to be an acid, okay? And if it's a base, it's red turning blue, blue base, okay? All right, number 2 says identify the acid in the following reaction. So up here, this first one right here, this is the problem that's on there. And they say to identify the acid, so usually the first thing we do is we identify an acid versus a base. So I'm going to take a look. Remember, we're dealing with the reactants over here. We're not really concerned with the products right now. So I'm going to take a look and see which one's an acid and which one's a base. So I'm looking for, if it's an acid, I'm looking for it to give away any of those H molecules. Okay, so I've got an H here and an H here. So I have to ask myself, which one gave one away? So if I look over on this side, you should be able to see that, where is it? This is going to be the base, and this is going to be your acid, okay? So, oops, did I have the wrong? That's why. I had the wrong thing on there. Hold on, page 3, CHO4. Okay, this is wrong. Hold on. Let me just write it up here correctly. This is why I was wondering what's going on. Okay. And there we go. Okay, now I take a look between this one and this one. And this one and this one. I can see that this one went up 1. And this one went down 1. So I'm going to draw an arrow. I'm going to take my 4, and this one's going to give it to this. So I'm going to note donor over the top. And then if I look over here, this is the one that accepted it. So I'm going to put acceptor over the top. Okay? So once again, if I look here, I'm really comparing the differences. This one looks like it got rid of 1. This one looked like it gained 1. So if it's a donor, that's the acid. If it accepts the H+, that's going to be your base. Okay? All right. So that's number 2. Number 3 says, some books define a base as a proton acceptor. Why is this just as correct as the definition as the one stated in the book? So if you think about it, the H+, it gets that charge when it gets rid of its electron. All it has left is that one proton in the middle, which is a positive. So it goes from just being a hydrogen molecule to a hydrogen ion. So it's just got that one proton, okay? So a base is going to be the one that grabs it, okay? So because it's given away its one electron, it now consists of just a proton. And if the base accepts it, then it gets another proton. So that's why it's called a proton acceptor instead of an H+ acceptor. Same wording. All right, number 4. Which of the following are polyprotic acids? Let's erase these as we go here. So we're looking from this one, this one, this one, and this one. Now remember, polyprotic, poly meaning many, protic meaning proton, so many proton acids. Okay, so the first thing you need to ask yourself is this an acid? And how many hydrogens does it have that it's going to give away? So let's look at the first one. I asked myself, is this an acid? Well, I can tell it's an acid because I have that hydrogen right there. If I split it, you can see that it's sitting right there. And so it's ready to give one away. So I'm asking, does this H have more than one? And I say, no, it's only got one. So that is not a polyprotic acid. Let's go to the next one. H2CO3. I asked, is this an acid? Yes. It's got a hydrogen there that's ready to get rid of one. And it's got more than one poly. So this is one. Yep. Let's look at the next one. CaOH2. Now, the first question I ask is this an acid? So I take a look and I see it's actually got that hydroxide, which is a clear indicator that that's a base. Usually the OH is associated with a base. It has no just H by itself to get rid of. So this is actually not an acid at all. It's a base. So it can't be a polyprotic acid if it's a base. Look at the last one. Ask myself, is this an acid? It's got the H. Get rid of. So I look and I see, does it have more than one? Yes, it's got three. So that is a polyprotic acid. Okay, so it's that easy, just making sure that it is an acid to begin with, and if it has more than one H attached to it. All right, number 5 says, which of the following units could be used as concentration units? Okay, so real quick, concentration is molarity. I'm just going to put this up here really quick. Moles over... All right, so remember, concentration or molarity just means moles over liters. So I can have any unit that's either moles or grams, because I can go from grams to moles with my chart here. I don't know where it is. So it can either be grams or moles on the top, or it can be a volume unit on the bottom. It doesn't have to be liters, because we can always switch into liters. Okay, so let's take a look at this first one. I've got milliliters over meters. So right away you should see this is a volume. This is a distance. That does not fit that standard right there. So let's take a look at the other one. Could this one be used? So I'm going to look and see, is it moles or grams? Yep. So I can switch to moles. And then on the bottom, is it a volume unit? And if you remember, meters cubed, it's the same thing as a volume unit. We could interchange meters cubed and milliliters back and forth, if you remember way back when. So that is a volume unit. So we could use this one. If I go to the next one, I've got moles, check, but I have seconds on the bottom, which is a time unit. That's no good. Okay? So that one is not one. And the last one, I've got moles, which is exactly what we need, and milliliters on the bottom, which isn't liters, but we can go from milliliters to liters, so that is one. So I would say that is a good enough conversion unit. Okay? All right, so let's look at number 6. It says, a chemist wants to make a solution of 3.4 molarity HCl. There are 2 solutions of HCl that he can find on the shelf. One has a concentration of 6 molarity, while the other has a concentration of 2 molarity. Which solution can the chemist use to make the desired acid? Okay, so he wants to have this. Remember, that's just moles per liter, okay? So he's got a substance that's 6.0 and 2.0. Okay, so this is on a scale. This is where we want to be. So in order to make this amount, this molarity, this concentration, it should make sense to you that you're going to want to grab the higher unit and dilute it. So you're going to add solution to it to make it not as strong to get to 3.4. You're not going to want to take something that's weaker and try to make it stronger. That doesn't make too much sense. Okay, so your answer is going to be that 6.0. All right, next. It says, this is number 7. When the compound Al2CO3 dissolves in water, what ions does it form and how many of each are present? All right, so let me write it up here. I've got Al2 3, 3. So they're asking when it dissolves in water, what ions does it form? So if you think about it, you could either go to your chart and see what Al is, and if you remember what CO3 is on your polyatomic ions, you could look on either of those. But if you're lazy, you can actually just undo the cross like this and stick these back on there. Okay, so the 3 is going to go to the aluminum, and the CO3, the 2 is going to go over here. Now I'm just asking myself, what are the signs on there? Well, if you remember, the aluminum is a metal, so it's going to be a plus. I want to get rid of those. And this is a negative, which should make sense because they cancel each other out. All right, and then it says, so these are the ions that it forms, these 2 ions. And then the rest of the problem says, how many of each are present? Okay? So I would just look back up here. You can see that there's 2 of these. So I would say there are 2 of these present, of these ions. And then if I look up here, I would say that there were 3 of those present, those ions. So hopefully that makes sense. This is the ion, the 2 ions that it's broken into. And then in order to tell how many we have, we just look back up to our original and see what the subscript is on those. Okay? All right, number 8. Let me get rid of this. This is number 8 right here. It says, consider the following reactions. So then they give this reaction and this reaction. And it says, which substance in the 2 equations is acting as an amphoteric substance or an amphoteric substance? It means the same thing. So remember, those terms just mean when you have one of those, it can act as an acid or a base depending on the reaction. Okay? So an example of this would be water. Okay, that's a pretty common example. There are some that we'll see as well throughout the course. So we're going to decide which is an acid, which is a base in the first and the second. And then we're going to look and see, did one of them switch? The same molecule, did it switch from being an acid to a base? So if we do that, really quick, I'm going to look at the first one. I'm going to draw a line. I can see that this is going to be the acid because it's going to give up its H, and this is an OH right here, which signals to me that this is a base. Okay? Now down here, I'm going to take a look. This one's not the same as this. It doesn't have the OH to signify that it's a base. So I'm just going to look between the 2. And if you look, I can see that right here to here, I gained an H on this one. And from here to here, I got rid of it. So this is going to be the donor. And this is going to be the acceptor. Which means this is the acid, and this is the base. Now we can answer the question they asked. They said, which one of these is amphoteric? So that means which one was an acid, which one is a base. So between these 2, I can see that I had HCO3, that was an acid here, and now the same thing, HCO3, is now a base here. So I would say, okay, it looks like this is an amphoteric substance.